Now we're going to consider the ability of halogens to act as oxidizing agents. Remember, oxidizing agents cause other substances to be oxidized, which means to lose electrons. And by definition, therefore, oxidizing agents are themselves reduced at the same time, which means they must have gained electrons. Always bear in mind what's happening with electrons in these sorts of reactions. Now, just to recap a little bit, remember halogen displacement reactions from IGCSE and GCSE, because this is tightly linked. At GCSE, you learnt that a more reactive halogen displaces a less reactive halogen, or halide ion, really. So just remember, fluorine is the most reactive halogen, and then as you descend the group, the elements become less reactive. So we can say that if fluorine was to react with sodium bromide, the fluorine would displace the bromide to form sodium fluoride plus bromine. So that's all balanced, and I've added state symbols. If we look at the ionic equation, just if you're not happy with this, just draw out all the ions like this. So I'm separating out those ions. So now you want to delete the spectator ions, so look to see which ions remain the same on the left and right hand side. They are spectators. So our final ionic equation looks like this. So for F2 to become 2F minus, it must have gained 2 electrons. So it must have been reduced. For 2Br minus to become Br2, it must have lost 2 electrons. So that has therefore been oxidized. So you can see how these are therefore redox reactions, because both reduction and oxidation have taken place. So just to really point this out then, because that fluorine has been reduced, remember what I said at the start, by definition an oxidizing agent must be reduced. So here's our oxidizing agent in this case. Remember, they could ask you about colour changes. So in this case, that bromine will be orange. If chlorine had been produced, it would be pale yellow or green, and then iodine would produce a brown solution. So here's a summary of all the halogen displacement reactions. So remember, a more reactive halogen will displace a less reactive halogen from its compound, which is why you always get a reaction with fluorine, because it's the most reactive. So for example, it will react quite happily with sodium chloride, sodium bromide, sodium iodide. Chlorine is less reactive than fluorine, hence why you get no reaction here, but it's more reactive than bromine and iodine. Bromine is only more reactive than iodine, so that's the only time you get a reaction. Iodine is the least reactive compared with these elements, so you'd expect no reaction. So to really summarize what I was just saying and make it very centric to A-level and IB, we're going to say halogens react by gaining electrons. So by definition, the halogen is reduced, such as in the case here. Halogens therefore act as oxidizing agents. Remember, I've already said that as you descend the group, the elements become less reactive. That means they also become weaker oxidizing agents. So fluorine is the most reactive and the strongest oxidizing ability. Astatine has the weakest oxidizing ability. As you descend, group 7, oxidizing ability decreases. Chlorine behaves as an oxidizing agent in the extraction of bromine from seawater. In this process, chlorine gas is bubbled through a solution containing bromide ions. Write the simplest ionic equation for the reaction of chlorine with bromide ions. So there's Cl2, there are the bromide ions. Chlorine is more reactive or acts as a stronger oxidizing agent, so actually you're going to produce bromine plus chloride ions. Make sure that's balanced. State one observation that would be made during this reaction while we make bromine, so we'd see an orange-brown solution. In terms of electrons, state the meaning of the term oxidizing agent. Causes another substance or species to lose electrons. Which of the following is not a correct trend of group 7? The first ionization energy of the atom decreases. That's absolutely true because remember, those atoms get larger, they have more shells of electrons, so it's easier to remove an electron. The oxidizing power of the element increases. No, we said it decreases. We said that at the top of that group, you'd find the strongest oxidizing agent. The electronegativity of the atom decreases. That's true. Remember, fluorine is the most highly electronegative element in that group. The boiling point of the element increases. Yes, remember, astatine and iodine at the bottom of the group are solids at room temperature compared with fluorine and chlorine, which are gases. Which of the following statements is true? Bromine liberates iodine from aqueous sodium iodide. That's true because bromine is more reactive than iodine or is a strong oxidizing agent.